absolutely graph every single point that we have on the unit circle, that will give you a much better shape. I will just show you what the shape is. The ones that I absolutely want you to graph are the 0, pi over 2, pi, 3 pi over 2, 2 pi. So on my graph over here, 0 is obviously right here. Okay. So going to do pi over 2. Pi. 3 pi over 2. And 2. Okay, so let's think about our ordered pairs on the circle here. At 0, my ordered pair is 1, 0, right? We're making a little table here. The x value, we're plugging in the angle here. So like, if this is my equation, I'm putting in a certain radian measure here, and my output is what the sine of that is equal to. So I'm going to start by putting in 0 radians. What is the sine of 0 radians? 0. Okay? So that's giving me the ordered pair 0, 0. So that is the first point on my graph. So I'm working my way around the circle. The next one I'm going to plug in is pi over 2. So the sine of pi over 2. So that's my next point. I go over pi over 2 and up 1. So we'll label a 1 on our line. So then if I plug in a pi over here, what's the sine at pi? 0. So I'm right back to 0. Then I'm going to do 3 pi over 2. Here. What's the sine there? 1. So put that on my y. My point's kind of going to get lost in my 3 pi over 2 there. And then what's the last thing I'm going to plug in?
0.
So yeah, I'm going to plug in 2 pi, which will give me a 0. Okay, those are the points you need. You have to draw the shape correctly, though. The shape is not like this pointy straight line graph. If you had actually plotted all of the points along here, you get this nice curve. So what it does is, does not do that. It starts right here, and you follow. What do you think it's going to happen after 2 pi? Yes, it keeps repeating. It's called a periodic function because it keeps repeating. This is the length of one period because that's how long it takes before it starts repeating again. Okay? So if you want to squeeze that in, the period, how long it takes. To repeat. So right now the period of this graph is 2 pi. I want you guys to try to do the same thing with the cosine graph. So think about it, about what you're putting in, all of that. I'll pass back quizzes while you're working on that. ever seen, but.
That's weird.
Yeah, because you have to rewrite thinking of it as y equals cosine of x and what. Yeah, I know it's a little weird. That's why we start making this table, just to kind of help you think about what you're doing. Oh, yeah, sorry. All right. So guys, let me take attendance before I forget, then we'll look at the cosine graph.
you're going to be on a competition we got based off of last year's competition. Something out there by pretty expensive. But all those good people are not mandatory.
What is that? Why would you do that? I love
Do you know this? So in there, they're like all of this. So if you're facing right, if you're just going to do it's X over
I'm walking at the colonial.
Alright guys, since you're looking at your quiz right now, I do want you to do quiz corrections. The way I would like you to do quiz corrections is just to do them directly on the quiz. If you can do it in like a different colored pen or circle it, just something so I can see the corrections. I know other teachers want you to do it on this other form. I like it on your quiz because then I can see this is what you did wrong and here you fixed it, okay? I collect them the day of the test, so you've got until then to work on your corrections. You can come in Warhawk time, ask me questions if you need help, anything like that. Okay? Alright, so let's get back to our graphing here. Let's see how you did on cosine. I am going to label the same things on my x-axis here. I'm going to label pi over 2, pi, 3 pi over 2, and 2 pi. All right, and cosine goes between -1 and 1. Cosine starts at 0, 1. Then at pi over 2, cosine is 0. Pi, cosine is -1. 3 pi over 2, it is 0. At 2 pi, you are starting over again. Okay. So what do you think the period of cosine is? Yes. So those are your two parent graphs for sine and cosine. You must know them. Alright, so let's turn the page. Does anybody, sorry, I know I went through that really quickly, are we? I'm just assuming we're okay with this, are we? No questions on cosine? We get it? Okay. Alright, then let's look at... Okay. This is the standard form for your sine or your cosine equation. That means there are 4 things that can change what your graph looks like. A, B, C, and D here, okay? I know it says on here for you to go to this website, this Desmos website, to look at it. I want to just walk you through, because I think you know a lot of them already, what the A, B, C, and D have to do with this. Think about the review worksheet you did. What did a coefficient out in front do to your graph? Stretched it. So A will stretch or compress. It will vertically, so it's a vertical stretch or compression. And with the terminology from the bottom of your page there, what this will do is change the amplitude. So amplitude is always equal to the absolute value of A. Okay, amplitude is never negative. So if you look down at that graph at the bottom, amplitude is like half the height of your graph. So it's from the midline to the top. That's what amplitude is. All right, B is the one that's a little just different from what you've done before with your graphs. That's inside the parentheses with your X, so for the other graphs you've done, that was like a horizontal structure compression. What it does with your tree graphs is it actually changes the period of the graph. So you know how right now it takes until 2 pi before it starts repeating? You can change it so it'll repeat every pi or every 8 pi. We can mess with how long it takes to repeat. So this changes the period. So to calculate the period, it's always equal to 2 pi divided by b. Do you guys also notice here how b has been factored out of this quantity? That's very important, okay? And I'll show you how that works with graphs, but that matters a lot. This b has to be factored out of whatever's in your parentheses there. I think you can tell me what C does. Yeah, it's a horizontal shift, so it will shift your graph left or right. And just like with your regular graphs, it's kind of the opposite of what it seems like it should do. Minus, you go to the right, plus, you go to the left. And then what do you think D will do? Yep, so it's going to shift up or down. And instead of just saying the graph, I'm actually going to say the midline. You guys see this midline down here? We'll reference that a lot. That also shifts. So it shifts the graph and midline. Up or down. Okay. So far, so good. All right, turn the page. We are going to walk through a lot of these together, so make sure you guys just have the process down for these. So y equals cosine of 4x. Only one thing has changed. What is that one thing? Yep. Okay, so let's think about it. What is the period now equal? Pi over 2. Yeah, because you're doing 2 pi over 4, so we get pi over 2. Okay. If we had graphed it and labeled everything like we did the parent graph, this first tick mark would have been pi over 2, right? So that means the entire graph of cosine would happen by the time we get to pi over 2. So if you were doing this with our normal labels, you'd have 4 of them by the time you got out to 2 pi. Okay? So that's another way you can think about it. This tells you how many of the graphs you'll see by the time you get to 2 pi. But for our graphing purposes, we're just going to change the label on our x-axis to match our period. Okay? So the way we go through that, I'm going to write here above it what our original labels were. Pi over 2, pi, 3 pi over 2, and 2 pi. And then I'll write underneath what we really want to label it. So if I just want to see one cycle of the graph by the time I get out here, what should this last tick mark be labeled? Pi over 2. And how did I find that? Like, what did I divide by? Four, right? Okay. And so to relabel the rest of these, you have to divide them by 4. So what is 3 pi over 2 divided by 4? 3 pi over 8. Pi will become pi over 4, yeah. And what will pi over 2 become? Yes. Does that make sense, what we're doing there? Okay. Because now that we've relabeled it, you just draw the graph like the parent graph looks. I'm going to go 2 tick marks to equal 1 on my y-axis just because they're pretty close together. So cosine starts up at 1. Then it goes 0, negative 1, 0, positive 1. So the graph looks very much like your parent graph, but it's completely different because you've changed the x-axis labels. Okay. It does say to graph 2 periods of the function. Could I go this way too? Does that make sense? It would just be these labels with negatives, and then it would mirror the exact same thing with period. Okay, just want to make sure we understand.
Go right on
So if I wanted to, this is what it would look like. Let's look at number 2. So we've got a couple things going on here. We've got a negative, we have an amplitude change, and we have a period. Okay? What is the period going to equal now? Period. Where it's 2 pi over my b, so 2 pi over a half. That equals 4 pi. Label your x-axis for me. Okay, you guys try, and then I'll put it up here and see if you got it right. You guys do pi, 2 pi, 3 pi, 4 pi? Yes? Okay. So we've taken care of the period part of that, so now we just have to worry about the negative and the 2. So I'm going to do it in like a lighter color here, just what the parent graph dots would be, what they look like. You don't have to do that, it's just to remind you. The sign is usually 0 and 1. You guys, okay, kind of neon. 5 is 0, then we're back to -1 and 0, right? That would just be the pattern for regular sum. This negative and the 2, the negative flips it, the 2 stretches it. You can do that all at once. All you're doing is taking your y values times -2. So what's 0 times -2? Okay, so are the zeros going to go anywhere? No, so I'll do those. I'll go to purple again here. They're not moving. What about this one that's at +1? Where's it going to go? -2. Okay, it gets stretched in, it gets flipped. Okay. It's all the way down here. What about the one over here at -1? Where's it going? +2, yes. Okay, and then you can okay, if you did the left side, up, middle, you're just following the same pattern. Now wait and make sure everybody's with me. I don't want to rush through this. So if you understand the first day of graphing here and the basics of this, it's just little pieces building onto it. But if this part, if I lose you on this part, then it's hard. All of it's hard. All right, let's go ahead and do number 3 then. So, what is happening in number 3? Yep, we're going right pi over 2. Okay. Is anything else happening? No. So my x-axis labels always where you should start. Are they going to be different than the parent graph? Nope. So let's label them. So we've got pi over 2. That's a 2. Pi. 3 pi over 2 and 2 pi, right? Okay. In my lovely neon green here, I'm going to do just the parent graph points. Just as a reminder, we're on sine again. And guys, I'm going to do the ones on the left side too. What you're going to do is take these green, lovely green dots, and we're going to shift to the right pi over 2. How many tick marks is pi over 2? Just 1, right? So you're just going to take this dot, move it over there. This guy goes over here. This one over here, okay? So, move it over. Move it over, okay? I can easily then draw on the right side of my graph. I'm kind of missing something over here. You can always just follow the pattern. So it's low, middle, high, middle, low, middle, high, middle, left. Okay. It will also be true that your ending and beginning point, okay, they should always match. So just another checkpoint. Okay, number 4, I actually want to change this equation. I want it to just say pi, not pi over 4. So I want you guys to try this one. Guys, make sure that x-axis is labeled. Walking around, I see a lot of unlabeled. So, don't, this seems to still be.
Oh, yeah, and then the track, yeah.
Yeah.
Yeah, the track. But the graph is fine, but the animals.
Yeah. Put it up here, let's see how we're doing. Okay, so first my labels. I over 2, pi, 3 pi over 2, 2 pi. We're okay with that, right? Okay. I'm going to do, oops. I'm going to just put those regular cosine points up here, just as a reference. Okay. Where are my points going? Which way? What's that one? Left by pi, and down 1. Okay. So to go left by pi, I actually have to go 2 tick marks over, right? And then I have to go down 1. So that takes me there. Okay. So over 2, down 1. Over 2, down 1. And then hopefully you're starting to see the pattern. Low, middle, high, middle, low, middle, high, low, yes, okay, get that started. Talk yourself through it if you need to, it's okay. On the quiz, you're like, I need to just go in the hallway and talk to myself. That's okay. That is what your final graph should look like. Ooh, hopefully you draw better than I'm drawing right now. Okay. How many did have it completely right? 2? Okay. Yeah? Did you fix it? Okay. All right. Let's look at 5. We are jumping in difficulty here quite a bit, okay? We do have to take out the 1/2. Very good. Okay, so let's rewrite this. So 3/2 sine. We need that x by itself, so I have to factor, so you can do parentheses, brackets there if you want. I have to factor the 1/2 out. What is that going to leave in there? X minus pi, yes. then plus 1. So we are not shifting to the right by pi over 2. What are we shifting to the right by? Pi, yes, okay. So we got a whole bunch of things going on here. What is the period of this one going to be equal to? Yes, because it's 2 pi over 1/2, which is 4 pi. So we've got new labels because of that. Our amplitude changes. Our amplitude is now 3/2 or 1.5. We are shifting to the right by pi, and we are shifting up 1. I'd suggest you don't do everything at once on your graph, okay? If you end up with a couple of different graphs drawn on there, that's fine. Tell me, like, use colors and say, hey, the blue one is my answer. Or make one a dashed line and your final answer a solid line. That's totally okay. You can have more than one graph drawn, as long as you tell me which one I'm actually supposed to look at. You can't just draw 7 and go, the one is red and she looks red. So, okay? All right, so we always start with our x-axis labels. So that last one I know is going to be 4 pi because that's my period here. What are the others? 3 pi, 2 pi, 1 pi. Are we? You'll start to see the same labels over and over. I'm going to go 1, 2, 1, 2. Okay, I'm going to go every 2. Since we have a 1.5 in here, it might be nice to have that. Okay, I am going to go ahead and plot some green points here. I'm not going to do just sine though. I'm going to do sine with the amplitude change. All right. So the zeros will still be zeros, but instead of going up to 1, where am I going to go up to? 1.5. Yeah, the amplitude changes to 1.5. So I'm going to go all the way up to there. Then 0. Then negative 1.5. I'm going to do the same thing on the other side, just so I've got plenty of points for my shifting. And guys, I'm even going to connect these, just because there's a lot going on in this graph. All right, so we're off to a lovely neon start here. What do I have left to do? Have I lost you? What do I have left?
Rising up.
Yeah, I've got my shifting, right? So I have to go right by pi and up 1. So let's do that all at once. I think we can handle that. How many tick marks is pi now? Just 1, okay? So I'm going right 1 and then up 1. It's sort of annoying that we've got this like 1.5 for our amplitude, but that's what we have, okay? So the next point, I go over to the right one, and then when I go up, that takes me all the way to 2.5. You guys with me? Okay. Right 1, up 1, right 1. So when I go up 1 on the y-axis, I'm actually at negative 0.5. You with me? Yeah, I know the paths are annoying. Right 1, up 1. Right 1, so your top, the maximum's always up to 2.5. Your midline is right at that 1, which should make sense since that's what we shifted by. And I end over there at negative 0.5. If I end at negative 0.5, where should I have started on the left? Yeah, they match. So this purple graph is my final answer. Question.
Here it says 4 pi, right?
Yes, it does.
I thought it was a star.
My 4 got a little. Okay. Let's pause here. We're going to come back and do more with the notes, but before we get to writing the equations,